If he thinks he needs
I
that.
just got the white.
Ben,
I know.
we're streaming this, so you're
Oh,
aware.
okay.
Or it's
So
about to go
let's
live.
talk loud.
It's just starting to start now.
All right. Okay, I'm gonna start with this trial stuff, Pete, and then we'll go to regular stuff. Okay, welcome to our weather discussion. Today is the 25th anniversary of the April 1st, 1997 blizzard in southern New England, and I wanted to talk about that a little bit today. Not very much, but luckily I had all this stuff prepared from research I did on the storm many years ago. So let's start with figure 3, Pete, if we can click on that. So this is from 06Z on the 1st of April 1997. It's a cross-section. I guess you don't know where it is. I guess we have to do figure 2 first. Stupid. Sorry. So it's going to be a cross-section right, this is theta E at 700 millibars. So this is the cold frontal portion of the structure. This is the warm front. And then there's this really beautiful occluded thermal ridge right in here. And I've shaded theta E by color too. But we're looking at this cross-section, which I tried to take perpendicular to the thermal ridge axis, but as perpendicular as possible to the adjoining baroclinic zone. So that's on figure 3P, if we can look at that. This storm delivered 30 inches of snow to the metro Boston area on that day, which I think exceeded the rest of the whole season's total, which for them is saying a lot. So here's the occluded thermal structure. There's the warm frontal portion of the occluded thermal ridge. These are theta E isotropes, and then here's the cold frontal portion. And then this is just, I didn't know how to just cut it off at the time. I do now, but I didn't know how to do it then. This is 312 degrees Kelvin theta E. And I chose this to be the next item of analysis because it's pretty close to the warm edge of the warm frontal bundle of moist isotropes and the cold frontal bundle and the warm frontal bundle. The next one higher you might say is a good one, but it loses some continuity when you go through time. So the one I've always, when I look at these occluded structures, I always take the one at 3 Kelvin intervals that's inside that one that at any one moment might look like the best. I like to look at the one that's inside because it's going to be more continuous. But I'll draw your attention to the poorly stratified air that sits in the occluded quadrant of the cyclone. This is the least stratified air in the entire cyclone environment, and that has ramifications for the precipitation production. So,
I want to point something out. That one that you said you don't like as much, the one that's
Yeah.
interior, it's the only one that actually slopes up on the Warner side. It slopes up toward the fold.
no, they both do. This one does, and all of these slope up. What do you mean?
No, on the other side.
Oh, this one here?
Yeah, see how the ones below are mostly flat, so you see the fold is coming down from the left. But that's the only one that actually seems to show some signs of an overfold.
Oh, except maybe the top of this one does.
Yeah.
There's a little bit of
The top of that one too,
convective
yeah,
instability,
a little bit, but
Yeah.
that's what I was looking for, to see if the warm side has anything to do with the folding process, pushing something over the top. That looks a little bit like that there, but not extremely compelling, but a little
Yeah.
bit.
But this one is the one that when you go through a series of these cross-sections at different times, keeps on showing up near the warm edge of both of the zones. This one comes in and goes out at certain
Oh, I
times.
see, okay.
So I always took the one that's inside. So now we'll look at an animation of 312 degrees Kelvin using this 5D over the whole domain. So that's right there, Pete. Oh, we're gonna be able to do this?
If it's an FLI, we may not.
Oh, I forgot about that. Rats.
Well, let me save it and see. I don't recall if I've got the FLI we run here or not.
I don't want to.
I'd say let's bail. I don't know if that's.
Oh, okay, yeah, sorry, unfortunately. Okay.
Yeah.
I guess I forgot that there's a format type that is important here. What I was going to show you is first the animation of that surface, because in Vis 5D you can look at an ISO surface of any variable you want, and 312 Kelvin theta E is really easy to make. And then you can see the trowel in 3 dimensions, that trough of warm air aloft to characterize the occluded structure going in through there. And then we were going to look at how that jives with the precipitation. I think that's not an FLI, so we might be able to try the other ones. I don't know. Let's try this one here. I don't know if that's an FLI. This one
That is an FLI.
Oh, it is?
Yep.
Okay.
I'm
So we
trying to
can't-
download them and see if I can actually play them.
Okay. Rats. I didn't think of that. This is sort of old.
That's so annoying.
Yeah, it is. It
Okay, so
is.
why can't they be backwards compatible?
Yeah, I don't understand.
FLI was sort of a weird format, though. It's kind of like GIF, but for animations. And we
You
use
can
that
break
for
them up into
quality
individual
was better.
GIFs, and then you can just run them as an animated GIF, but I can't do that on the
there we
Okay,
go.
great, we can do it this way, excellent, fantastic. So here's the 312 degree Kelvin theta E. I make it opaque and then you can see through so you know where you are. We'll do that again. So right in there is the trough of warm air aloft. And notice where it's going to be geographically, right over southern New England during this whole event. And it doesn't exist throughout the whole evolution, it exists as the storm becomes occluded. Okay, so let's try the next one, Pete. Thank you, Pete, for that quick.
312 theta E.
Yeah, I forget which one it is. Let's see if that's right. This is the one with the trajectory. What is it called? Yeah, I guess it's just from a different view, so we'll do this one. Thanks, Pete. This is just from a northern tilted perspective, and you can see that. Ooh, just this.
Sorry, I'm trying to get it to loop. I think this thing should.
Pretty darn good, Pete. So here's the trowel structure right in there. Remember, this is one theta E surface, and so you can kind of see how it folds over itself, and that fold has a three-dimensional nature to it. It tilts upward and poleward in the storm. This is northern Canada, this is the Caribbean. Okay, let's go to the next one, which was called what again?
This is no theta E.
No, we want to do the one with the
All right.
with the trajectory on it first, and then we'll show the snow. So let's see. I guess that was the next one in the line. Let's put this one. Let's do the snow one first, I guess. I don't want to spend too much time. That's kind of not working out quite the way I hoped. So here is the same thing you saw before, but now the accumulated snow from the model. It fits right in the occluded quadrant, beautifully, like that. So you can't miss that. And then let's take a view of the same surface, but from an elevated northern perspective with an airstream, a trajectory that's in it. It's this one here. Oh, that's working fast. Yeah, bottom. Okay, so here's a bunch of air parcels, and they're color-coded by the pressure level they're at. Red is really high pressure and blue is low, and they come right up the gut of this thing, turning anticyclonically as they, or cyclonically as they do so. And that's the rising air that forces all that heavy snow. And the question that I had at the time was, is that a function just of moving up the isentrope, or is there something more dynamic to it? And it turns out there's something a lot more interesting and more dynamic to it than that. One can invoke a secondary circulation to explain the vertical motion there in a really nice, elegant way. In fact, the forcing for the vertical motion also conspires to force the thermal structure to evolve the way it does. So they're kind of all tied together in a nice way in this event. And then one last one, Pete, is going to be the animation of that same airstream from a plan view with sea level isobars. You can see how this is all happening as the storm develops. And I guess it's that one there. So there's the sea level isobars that are in white. They're color-coded as well. And this is the trial airstream, no longer color-coded, but it starts at about 800 meters down here in the warm sector, and then becomes coherent and rises about 6 kilometers in 12 hours from about Narragansett Bay to back here near Albany. So that's where all the ascent's going on. And remember, that's where the heavy snow band was as well. So it's really a beautiful depiction of how this storm was both evolving in a thermal way, evolving in a dynamic way, and paralyzing parts of southern New England with heavy snow. That's 25 years ago today, so I wanted to show that. Pretty cool. And it's part of a paper in the monthly weather review, I think from 1998, perhaps, something like that. So anyway, if you want to read about it.
Hey, John.
Yeah.
How well was this forecasted?
This was a pretty decent forecast. I don't remember that the Boston area, because I'm in contact with, that part of the world a lot. My parents live there. I don't think my dad knew they were going to get 30 inches of snow. So I don't believe this was a giant forecast bust, but on the other hand, maybe they forecasted 10 inches and they ended up with about 30, that's kind of a bust. But 10 inches on April 1st is a big event. Everybody knew it was going to be a big event. Maybe just not how big. And in terms of the thermal structure, I don't recall what the operational models looked like thermal structure-wise, but I would have no reason at all to suspect that it wasn't well forecasted in the way that it evolved. And this is Greg's NMS model that we put into this 5D format, so we ran that simulation. So it was, I think it was pretty well forecasted, but I really don't recall it. So. Okay, thanks, Pete. Let's go back to our regular weather watch now. And Pete, thank you for that incredibly speedy, Pete on the spot solution to an otherwise intractable problem that Greg and I were both bemoaning. So let's start with our satellite movie over the continental U.S. And I'll begin, as you're watching this, this winter has been boring. I've said that a million times, and you're all shaking your heads, not only agreeing, but saying, shut up, enough. Okay, but I want to just add a couple of more points to that. The most snow we got in a single month this year in Madison was 9.1 inches in January. We didn't get 9.1 yesterday. We got, I think, maybe 2 Pete had us, maybe 3 at his house. I don't think I know what it was at the Weather Service observing site at the airport, so maybe we can take a look.
Yeah, it looks like about 2.
Okay, maybe about 2 inches. So we're way below, we're still not at 30 for the year, which is right there. So that's an unusual characteristic. I think 1 in 10 or 1 in 12 winters gets that little amount of snow.
Ed emailed me that he was gonna put 20 inches on here just to see if we noticed.
But get up to the average. Now, the reason I say 9.1 in January is because when Michael will talk about the forecast in a minute, I can't help but let a little bit of the cat out of the bag. Next Wednesday and Thursday, we have a chance for a really substantial event. And last week, on Wednesday and Thursday, we were talking about the one that came in the right magnitude, a couple of inches of snow. So let's just say that that forecast made today is going to be about right. So we're maybe in the 5+ inch range on next Wednesday, Thursday. We only need one more such event to end up having April be the snowiest month of the winter. Which I'm sorry I didn't have time to figure out whether or not that's ever happened before. I have a suspicion it could have happened one other time. But if so, only one other time. So this would be a really dramatic situation for us. We would rescue this otherwise boring winter from infamy by
Bring it on.
Yes, I'm asking you all to ask to bring it on.
I think in Colorado, April is the snowiest month in the winter.
That's probably right. That's probably right. We're pretty different around here. So I would love to see that happen. If that happened, I vow I will never complain about a boring winter ever again if we get to that point. So you can all hold me to that. Okay, so here's the satellite movie over the continental U.S. and adjacent waters. Lots of interesting things going on here today. This storm that kind of came by us is getting better and better organized as it moves east. Look at this cold front, all the way from maritime Canada down to the northern states of eastern Mexico and across Florida. I think it was heavy rain in St. Pete today, and then a little bit on the west coast, the east coast as well. And the only warm spot in the country was really Miami and the southern tip of the peninsula. They were in the 70s, mid-70s this morning. Everywhere else, New Orleans had a dew point of 48 today with a temperature of like 59 or something this morning, maybe 69. Beautiful day in New Orleans. You don't say that too often, with a low dew point. And the low dew points just about everywhere in the eastern U.S. Beautiful day. So a nice presentation for this cyclone as well. It's got like I already said, the cold front, the warm frontal cloud band extends to the southeast a good distance. There's another gyre kind of going crazy in the southern Labrador Sea. It's been a very active period in this part of the world this last couple of weeks. And then to our northwest, over, I guess, sort of over Lake Winnipeg, there's a pretty decent looking cyclone in central Manitoba. And that is going to have some impact perhaps on our weather over the weekend. But there's also a circulation brewing in the plains of Colorado. So these are connected by some sort of boundary in between. And this is a new circulation. So the whole progression of that set of waves is bound to hit us at some point over the weekend. We'll see exactly when and in what form when we get to the forecast.
It's good that you had mentioned the low dew points in New Orleans.
Yeah.
And I imagine in southern Florida, they're probably in the 60s or maybe even higher for dew points.
It's the only place
And you
left,
can
yeah.
kind of see the convection beginning to pop up south of the front over the southern part of Florida. Compared to anywhere else in the southeast, you don't see the cumuliform clouds.
Yeah, none at all. I mean, it's not only broadly and gently subsidence, but there's just nothing left for the water vapor. That's right, it's a combination of things there. And then when you go further to the north, widespread open cellular convection, not all of it precipitating, we'll see in the radar, but some of it over Ohio and western Pennsylvania is a stream of really chilly air coming across Lake Michigan. It's like minus 10 or 12 at 850 over Lake Michigan. And the surface temperature is just around 40 Fahrenheit, so about 5 degrees C. So that's a super adiabatic lapse rate over a moist boundary. So no surprise, we have some widespread convective cloudiness. And as I say, as they develop and get a little bit deeper, they end up with a little bit of precipitation coming out of them too. We'll see that in the radar. So it was perfect timing for my class because that's just what we're talking about, is stability. So I couldn't resist talking about this situation right in our own backyard today in a little bit of detail in class. Look at how clear it is, though, as Michael points out. Not a cloud in the sky for a huge part of the real estate of the continental 48. And then also again in the west. It's widespread clear skies there as well. Low stratus clouds off the southwest coast of California, and then also off the Baja Peninsula. And probably not exactly stratus here that's coming on shore in the Pacific Northwest. We get a little bit of an oblique view there, so we'll see when we go out there.
What is this stuff?
Yeah, I don't know.
It was probably, that's the visible, so it's gotta be clear there, or?
Yeah, sometimes you get these hexagonal clearing spots in the stratus that almost mimic the hexagonal cloudy spots. I've seen this only a few times. I don't know what actually does that. I wonder what the answer is. Is that a cloud microphysical thing, maybe, Angela? If it's real,
It
first of
seems
all.
too big to be a ship track.
No, it's, yeah, it's.
It doesn't look like open cellular convection.
Yeah, are you
It's
able
not
to zoom
cellular.
in on
I'm
Sorry,
sorry,
look, it goes what?
it? Can you zoom in on it?
yeah, let's go,
Because it is really interesting. And I think I've seen the edges of it look hexagonal.
I think it would show up on this one. Is that too far? That's too far north, isn't it?
Yeah, unfortunately.
I think I'll look at it as the color one.
Oh, there it is.
Oh,
Yeah.
Oh, you're right. It is open cellular.
Yeah, doesn't it look like that?
Yeah,
Looks like little honeycombs.
yeah.
So that would, open cellular convection is associated with forcing from below. You know, the closed cellular convection is where radiative cooling at the cloud top is the primary mechanism.
Oh, yeah, okay.
But the open cellular is when upward motion, like warm water or whatever. So there's some kind of a switch between mechanisms from closed cells to warm cells.
Hmm. Yeah, no, that's really interesting. I wish we could get a really intense view of that. It won't show up on the meso view because no one else will care except us. But it would be really nice to see that. Sorry?
You can see the von Karman vortices on.
Oh, yeah, look at that, yeah.
I should do like a close-up of that area and all the time. I bet every other day there's
Yeah,
this.
that's really cool.
No, it's
yeah.
not unusual, but.
What island is that? Is that Catalina?
Is that, no, that Catalina's part of the US. I don't know what
It's
this
off of
one is.
Mexico.
What is that one called? I don't know the name.
Oh,
of
that's,
that.
Is it SC?
It's beautiful. What is it though? Wait to that. Okay, so that's a very interesting feature. And you know, the stratus is all summer long. There's all kinds of weird things that you see in the stratus. It's definitely worth attention to take a look at it every day, especially here. You can see these vortices a lot more frequently as we warm up. But even these interesting hexagonal open cells.
those, the transition between the open and closed cells is always an interesting place. That's where you get these actinate, which are kind of spiral bands.
Oh, yeah,
that
yeah.
form on the intersection between those two. I don't see any there today.
Yeah.
They're pretty rare, but we've seen them before. You've seen them.
Yeah.
I'm not sure.
Yeah, very cool. Okay, so let's go to the radar across the country, Pete. Get a different perspective on this lake effect cloudiness precipitation. So you can see the cloudiness is evident over Indiana and parts of Michigan and then western Ohio, but the precipitation echo doesn't stop until you get to central and eastern Ohio. And I think the clouds are just growing. The ground's relatively warm. They didn't have snow as a surface boundary over the last couple of days. So you get a little bit of a head start with free convection certainly occurring as the air comes over Lake Michigan, and then it's maybe at least sustained, allowed to grow when it gets over the warming ground over in West Virginia and eastern Ohio. So open cellular showers, I think they're all rain showers. We'll see that in just a second. And then some of these up in New York State may be rain and snow mixed. And then here's the heavy precipitation across the central part of the peninsula of Florida. And circulation is a little bit evident here in southeastern Colorado. Maybe I'm imagining it, but I'm putting together both the satellite movie and the radar and kind of coming to that conclusion. And then there's just band of precipitation, which seems to be part of the connecting tissue between this and the feature in in Manitoba, which doesn't have any precipitation across Minnesota. So that's the picture across the U.S., 48 states anyway. So let's take a look at the West Coast satellite image. Maybe we'll get a different perspective on that feature that's just beginning to invade in the Pacific Northwest itself. might have seen just a few echoes across the Olympic Peninsula in the last image there on the radar. And that's as this disturbance, which is actually centered further along the British Columbia coast, comes in with its probably post-cold frontal shower activity, because that's what it looked like in the radar. Here's a little cold bubble aloft just south of the Aleutians, tracking to the north and east. I don't know how cold, maybe 35, minus 35 or something like that. And then, just to put you in the right perspective, where's Hawaii? Hawaii.
Right here.
Oh, right here. So we're well into the tropics down there. So there's Hawaii, the northern border of the tropics, and there's a little disturbance that's forming at about 29, 30 degrees north latitude there. But even in the infrared, one sees it's sort of an absence of clouds over much of the southwestern U.S. and no really well-organized weather system in the Pacific Basin. And I've said this a lot this winter, unfortunately, sorry to bore you, but I've looked at these Pacific satellite movies nearly every other day at a minimum, sometimes every day, and I just haven't seen any of those beautiful rolled up cyclones this particular winter. It's just been one of those winters. So, too bad. Okay, let's take a look next, Pete, if we can, to go to 500 millibar.
Surface map? You wanna do surface map?
Oh, surface map. Yeah, thanks for helping me remember. We wanted to see where it might be snowing in some of that lake effect precipitation. So there's some snow in northern Pennsylvania, light rain near, I think that's near Cooperstown, light rain at 10 degrees warmer in Albany, even warmer still. Is that White Plains or is that too far north? And then a little bit of snow here at near Buffalo. So the temperatures, and it's snow 38 over 31, so it's struggling to stay snow. It's like what we had on Wednesday. The same is true actually in Pennsylvania, 34 over 25, so that's all sublimation supported. And chilly and rainy over parts of northern New York and northern New England. And then no substantial rain across Ohio, at least in these sets of observations, and then light snow near Pittsburgh. 40 over 26 seems almost, that's got to be about the limit, because the wet belt temperature has to be 32. I think that's about the limit right there. So, and then substantially warmer as one heads to the south and east. And if we go down all the way to Florida, you'll see that even more dramatically, especially, I think, in the dew points. So here's New Orleans, 68 over 46. It's a beautiful day there. 69 over 42. Coastal Mississippi, 86 over 74 in Miami. That's miserable. Nobody wants to have a 74 dew point. I don't anyway, put it that way. Key West, 76, even worse. And everywhere in the Central Plains, where just on Wednesday, we had dew points in the 60s over this whole region. The cyclone was up in Iowa. The one that gave us snow later on was up there, and the cold front was draped across Texas. The dew points here were all in the 50s and 60s, and now they're 20 or more degrees lower.
Wow.
On that air.
On the,
across.
That's not Bay of Campeche, but the further south. Sorry, just in eastern, right there.
Oh.
79, 86 over 79.
Yeah, that's unbelievable. Is that, wait a minute, is that, Cozumel? Yeah, I was trying to think of the name. It's 86 over 79. Woo, that's brutal.
The water's not that warm, is it?
Huh?
Is the water that warm?
I guess it's got to be at least 73. So maybe it is. Wow, 79.
The one just north of it is 75. Dude.
Yeah, that's right. So that's really pretty intense for humidity. Wow, unbelievable. Contrasted with the plateau, 72 over 10. That's awesome. That's probably the best one, the best pair we have on the whole map. Whatever that station is in Mexico. Yeah, no place in the other parts of the world where you can get such depressions is really that dramatic. That's great, 72 over 10. Oh, Bullhead City. You got to go to Bullhead City, Arizona, and Death Valley. Even there, nope, nothing quite like it. Those are almost muggy days for Death Valley, 38 dew point. What are they doing? And then think a little bit of rain up in the Pacific Northwest. Yeah, right on Vancouver Island, but I thought there was probably some in the peninsula, but not enough observations, or it hasn't quite gotten to me yet.
And that circulation you mentioned over southeastern Colorado.
Oh, yeah, it's down in here. So here you can see that at least 2/3 or 3/4 of the circulation. Very warm to the east and then cooler to the west with dew points are about the same. So 46, 59, 62. So there seems to be a circulation center here. We saw precipitation stretching into the South Dakota. There's light rain there, and I don't see any snow even at the higher elevations, 36 over 27. Is that Durango? So kind of cool. Where's Benji? Maybe he doesn't know all the Colorado stations.
I don't know, I was thinking Telluride, but I'm not sure.
You're probably right, Benji. I'm just going to take your word for it. He's like Prince Henry the Navigator back there. He knows every single city.
I think Durango would be the 34 over 23 one, just to the south.
Oh, right here. Okay, yeah, that's probably right. And then we had that pretty decent looking system around Lake Winnipeg, and that's all snow, so you can see the obvious circulation around that. And that's a pretty decent circulation. So that's the table setting for the coming weekend. Let's go to the 500 millibar map, Pete, if we can. I'm sure the 12Z's in now. Yeah, so this is 12Z this morning, and here's the upper trough associated with the storm that we saw sort of over New England and adjacent states. And then the cold front was draped across Florida, as you remember. So that's, we saw a few hours after this, but that's a pretty sharp upper trough. Not really a very big downstream ridge. Sometimes that's part of the, I think part of the reason that the cloud mass for the cold front just seems to go up and then turn asynclitically. You don't really see anything develop back here in terms of, cloudiness in a more coherent comma shape. I think the flow is just a little bit too stretchy in this direction and not vortical enough. And then it looks like, even at a glance, and we'll see how this turns out in the forecast, wave number 1 is our storm in Winnipeg. Wave number 2, connected perhaps to it a little bit, is almost a separate vorticity max. I suppose it is a separate vorticity max across Colorado. And then it looks like the genesis for wave 2 and 3 maybe into the future. And then another feature up here, this is a low geopotential height minimum as well over the western archipelago. So I don't see how we're going to escape the close approach and maybe, near hits of some of these waves that are upstream, because the flow is not determined anyway. It doesn't seem to be determined to become zonal. It's zonal all the way out near the Aleutians, but it certainly isn't over the continental U.S. So we may have a progression of waves, one after another, for a period of days here. And so long as the flow stays slightly northerly, even if not directly northwesterly, it's hard to warm up as well. I like to see a strong zonal flow across the continental U.S., and that warms us up at almost any time of year. But if it's not zonal and it's kind of parallel to the Rocky Mountains, that keeps us chilly if we're already chilly, which we are now. Let's see 300 millibars, Pete. So at 300, some of these features don't really even show up as strong jet features. The only ones that do are the more zonal jet near the date line or close to the date line, and then this jet that's probably a combination of the polar and subtropical jets, along with the development that's going on over New England and maritime Canada. And then in between these two waves, well, especially this wave, doesn't look like it's strongly supported by a polar jet streak, although 100 knots in western Montana is, not nothing, but it's not a gigantically strong northwesterly flow event. Let's see at 200 millibars if we can differentiate between a polar and a subtropical jet, and that's an easy way to do it. And it does look like the southern appendage of the 300 millibar ice attack max was probably the subtropical jet. But they're superposed over the middle Atlantic coast, or nearly so. In fact, let's see, that's the maximum at 200. Let's see what it looks like again at 300, same, keep my pointer there. Yeah, it's just about the same. So they're just about, that's a deep jet structure. And this is what I meant by the appendage. That looks like the subtropical jet. This looks like whatever's left of the polar jet. So that's the setup, a broad trough over the eastern 3/4 of the United States. The temperatures at the surface reflect its presence. They're chillier than normal. It's not bone-chilling cold. In fact, it strikes me that in April, if the sun is out, you don't even remember it being a cold day. And if there's clouds in the sky and the air is like this, it can be a really cold day. So as long as it's sunny, it doesn't make any difference, even if you have this deep upper trough over your region in April. But will any of these disturbances carry clouds with them, stay cold, and therefore get us to or below freezing and give us precipitation in the frozen form? We'll see when we look at the forecast. So that's all I have. Michael, you want to take over?
I'll be brief.
Okay.
But first, before we do that, I want to go to I have some images that I want to put in the folder that's open.
I think I closed that folder. So it's just on your desktop.
Yeah, it's on the desktop. No, actually, it's not on the desktop, so you gotta go here, double click on that, and then it's Weather Watch. Then Vrabel first. And the first one I'm gonna do, this is just a more of an interesting, I don't have much to say about it unless folks that work with the Antarctic Research Program have anything to say. This was an observation from last week from Concordia Station in Antarctica. This is the time series of the daily average temperature at that particular station. And just one day last week, they were several degrees Celsius, 90 degrees Celsius above normal at that station, which is just incredible. I mean, it's the warmest day ever recorded against at that station for a daily maximum, which is just a fascinating thing. But I don't.
You know, if it really was just the clouds, as the first report seemed to suggest, the clouds are transient, so it should have just dropped back down to climate and they disappeared, right? I don't know what happened after this
Yeah,
fact.
it's like there are at least two there, so it didn't quite just drop back down. So
Yeah.
But that's just a really
It's unbelievable.
fascinating observation and just another sign of some oddities in our weather and the
That's
climate.
probably 90 degrees Fahrenheit though, right? That looks more like about 45 or 50 Fahrenheit.
Celsius, yes, that's right. Okay, thank you. 90 degrees Fahrenheit.
Still,
It's warm.
that's ridiculous.
All right, but getting closer to home, so we can go back to that set of images. I'd like to go, not that one just yet, drought page. So we've been talking off and on over the course of the last several months about the drought that's been gripping the western part of the United States and the drought conditions even over southern Wisconsin, northern Illinois, and eastern Iowa. And sort of the outlook is for this drought to persist in these dark brown areas, and maybe even further develop in the yellow areas, but maybe some improvement over us in our precipitation prospects, at least for this upcoming month, look pretty decent, but then things fade as we go further into the spring. But, you know, one of the things, why do we care about looking at drought and drought tendency and things of that sort, is, you know, we're an agricultural state, and there's a lot of agriculture in the upper Midwest, corn and other sorts of grains, and soybeans, things like that are grown, and with, supply chain issues, with issues related to fertilizer and things of that sort, as well as the conflicts out in Eastern Europe, there's going to be situations, the possibility of food shortages and things of that sort. So what does it look like for the prospects of grain and corn? Go back here.
Just one more about Hawaii. It looks like there's been an absence of Kona lows. And that
Right here.
suggests an extended jet has probably been the domain average.
Is that consistent with what you've
Yeah.
been doing the Pacific Basin a lot?
Yeah, it definitely is. So that's really interesting that it shows up. And that's a small part of the Pacific Basin, but a really sensitive one, as it turns out. So how do you like that?
Drought there. Is that also consistent with La Nina?
I don't know. That's a good question. I don't want to say because I don't know off the top of my head.
Let's go back here. We've got another image, which is this right here. Just kind of neat. This is corn areas in drought. These are the major crop areas for corn in the dark green. And you can see a significant fraction of this. In fact, 33% of the corn production area is in an area experiencing drought as of just a few days ago. And so prospects aren't looking good, because this area is going to remain in drought. Yeah, we have some improvement coming up just during as we move toward the planting season, but what's going to happen as we go a little bit further into the season? Just kind of interesting perspective, looking at the intersection of not just the weather that we talk about on a regular basis, but weather and some other economic indicators or things that are related to the quality of life in terms of food production. Just wanted to share that prospect. So what's it look like going ahead for the, we'll first look at precipitation prospects. This is again the seasonal outlook for precipitation from CPC for April, May, and June. And at least for the eastern part of our state, it looks like we have a slight chance of being above normal or leaning toward above normal for precipitation. But again, a vast portion of the country, western and southwestern part of the United States, remaining below normal precipitation-wise. And for the rest of the state, the upper Midwest, sort of equal chances. It's unclear, not a very clear signal in the data whether it would be above or below normal precip-wise. As for temperature, again, if there are questions or something people are
I guess
interested
like a
in.
comment, I think the National Weather Service put out that this March was Madison's sixth wettest March, so even though we didn't get a lot of snowfall, so obviously.
That's nice, yeah.
I looked at, after we'd shown the snowfall rate, though snowfall in March is pretty much plateaued or little stuff, we almost caught up to Madison's average
Yeah,
in
yeah.
the season of March.
At least a couple of those really notable rainy days. Yeah, I didn't think about that. That's a good point.
Okay, so. And then for temperatures, well, we've been chilly, but it looks like as we go into spring, things likelihood of being above normal for a good part of the, almost probably 70% of the U.S. at least continental United States possibly being above normal. The only exception here is in the Pacific Northwest, unlikely being below normal.
This is complicated to me, because you'd think if the Southwest is above normal and dry, then the above normal would be really exceptional, and they suggest that. But wouldn't that put sort of maybe an anomalous anticyclonic circulation there that might suggest it'd be difficult to establish the subtropical high off of the mid-Atlantic, which warms us up by the time you get to June and July, you know? So I was expecting we'd see cooler than normal in New England.
Right.
But
Particularly
it's
with
not
that
that simple.
precipitation, you know, the possibility of
Yeah.
higher than normal precipitation over there. So
It's
that's
just not that simple, I
Right.
guess.
maybe something to look at. Later on, we can look at some of the things that go into this particular forecast, and maybe at a later weather watch.
How'd you like to be Hawaii on both of these maps? They don't even show up.
I mean, that's a good point. But they're out there.
Yeah, they're out there.
Okay. Let's go to the Psalm of the AOS that was to review, second tab, please. And we'll go down to our favorite, meteorograms.
We missed the meteorogram last week.
Sorry, good to be here. But looks like, again, a possibility, or likely warming up after a pretty chilly week, getting into maybe the low 40s, perhaps, if you just take this forecast explicitly. I wouldn't. And dew points beginning to moisten up a little bit, and the possibility of just a little bit of precipitation late tonight, early during the day tomorrow. So one of the big questions is it going to be liquid or frozen? But if you recall, if you go to the time height section, John was focusing on a trough that was out to our west. You can see it pretty evidently at 500 hectopascals from Manitoba southward into the central Rockies. And so we'll see that trough is going to be progressing toward us as we go. Pete, if we go to the time height section, we'll see that in the time height section.
Matt Lazara had commented when we were talking about the Antarctic temperatures. He said the high was minus 10.2 Celsius at Wisconsin Dome C to AWS. High was minus 11.5 at Concordia Station, and yes, afterwards the temperatures went back to average.
Oh, interesting. Okay.
Thanks, Matthew.
Thanks, Matt. So here is our time height section, time running from left to right here, and it's really a nice, almost a classic picture of an upper trough. The green indicates the dynamical tropopause, 1.5 conventional vorticity unit surface chosen for that. Yellow are the isotropes, and you can see these isotropes are buoying up nicely beneath with local potential vorticity maxima, and then going downward, indicating warmer temperatures and a higher stratification in this region relative to areas upstream in time or downstream in time, upstream in time, relative to the position of the trough as it moves over us sometime by midday tomorrow. Ahead of the trough, we see ascent occurring as the trough is approaching. Again, this is time running this direction. So this is as the trough is approaching, we're seeing significant ascent. We're seeing the column beginning to moisten up, and that's roughly at the time that we see the precipitation beginning to arrive at the ground here. Then once the trough goes by, we get subsidence, broad subsidence, and that's where the precipitation shuts off. And what a curious feature of this trough as it arrives is this really strong stable layer that we have near the surface. And I think this really extends well to the east of the trough as well. And I think the lack of a really significant surface development with this system as it goes by, it's a pretty decently sharp trough, is going to be in part due to the really extreme stratification we're seeing here. So you're not going to be able to get a significant circulation spinning up at the surface. Great.
Is the fact that the winds on this meteorogram are parallel to the isotopes, is that just a coincidence, or is it?
No. These are, I think just coincidence, because these are the horizontal winds.
Oh, okay.
Right.
Yeah, 'cause it
Sorry,
looks
yeah.
like a,
Oh, I see what you mean.
Yeah, it's not.
I see what you mean.
Oh, yeah, it looks like they're going up and then going down. No. This is just the horizontal winds, and this is a westerly wind. Ahead of the trough becomes more southwest as the trough approaches, then northwest wind.
It does look like that. I didn't see
I've
that.
never actually explained the winds on this. I
Yeah.
talked about everything else but the
I'm
wind.
glad I didn't see that, because it would have thrown me off.
I don't look at it that way, but yeah, so here are the southerlies and then the northerlies once the trough goes by. And again, you can see establishing even today with the snow cover that's melting, we develop somewhat of a mixed layer in the lower troposphere this afternoon. Not so much tomorrow, kind of tried, and then on Sunday, I guess with clear skies, we probably are able to break that mixed layer again. But it looks like a cloudy, damp part of the weekend, Saturday into Saturday evening. Okay, so what does this look like from above? We'll look at a weather map. We'll first look at the 305 to 315K PV, and I guess we'll just go to 6 hours on the forecast. We can step through it. Here's that trough in the, it's, you know, maximum in PV, the minimum geopotential that we see with this trough that's over Saskatchewan at this point, and you can see the high PV goes all the way down into northern New Mexico. That nice not really cut off, almost cut off potential vorticity maximum over the northeast, and beneath that swirling maximum PV, the large-scale geostrophic circulation was supportive of some of the precipitation we saw at the surface. You get Ekman pumping and ascent, frictionally forced ascent with an unstable layer beneath it. Any breaks in the clouds are going to quickly fill in and produce those convective showers that we saw underneath the upper trough, and that continues to move out. Let's go to 18 hours into the forecast, 12 hours from that last image. You can see that beginning to move off, that trough moving off the map, and here's the arrival of this upper trough again. We saw this passes through us by midday tomorrow, and you can see it's just to our west later this evening, or at 1 a.m. Tomorrow morning. Let's go ahead, again, another to 30 hours of the forecast, and that's just when the trough axis is just about over us at this point. So by this time we expect the precipitation to end. Trough continues moving out, and here comes the next one that was out over the west coast of the United States, beginning to move into the northwest. So let's go ahead another quick. I'm going to do this actually every 6 hours. Because one of the interesting things that we'll see ahead of this trough as it approaches. So this one is still moving out, okay, tomorrow afternoon. But watch what happens to the potential vorticity in this layer. Again, this is on an isentropic surface, and so we anticipate that the potential vorticity should be conserved. So any changes in PV should be things that we could explain through advection. So if we go ahead another 6 hours, just watch the colors there. Okay, this is still moving eastward. Just keep watching, I guess. We're going to get to 48 hours. We begin to see just a little bit of an undulation here in the PV contour. That could presumably be through advection. Keep clicking. You're going to see that there's going to be a change that's not going to be easily explainable by just simply advection. This little wave-like structure that forms here, which is also helping to sharpen the potential vorticity gradient and sharpen up the trough. We go ahead one more, the last click we have at 60 hours. Okay. And we sort of eat into this potential vorticity, which is indicative of very high precipitation, likely very latent heating. This is above the surface, so it's not going to be frictional, curl of frictional force leading to dissipation or redistribution of PV. This is indicating that there's significant precipitation ahead of associated with this wave. And I think it's going to be this next disturbance as it moves by us that gives us our biggest chance for significant precipitation, maybe snow, if it's cold enough when it goes by. Yes, Greg?
That 310K surface should be pretty close to the ground over the high plains.
Yeah, but we can, if you look even further up one other isotropic level, 10 degrees K further up, you also see this. 310, it depends on what the surface temperatures are, right?
Depends on the surface pressure, but along the front range there in the high plains, it's about 850.
Mm-hmm.
So 310 is pretty typical for just a normal daytime temperature.
Right, well, this is where you get the surface outcrops right here.
Yeah, right.
So it's above, it's maybe not.
So it's pretty close.
Yeah.
You're not that far from the blocked out.
Right. But the key thing is this notch that gets eaten out of here, which is not just through advection, it's going to have to be through a non-conservative process.
Yeah, and the lower 0.3 PVU, the light blue shows up in only the prior couple of diagrams. It wasn't there before. So
Right, so it's growing in size. And so if we actually look at this final time, let's look at the precip in the last 6 hours. Right, here's that precipitation right here. So let's actually, before we get to that precipitation, again, we have the 540 line. We're cold enough for possibly frozen precipitation. The season's getting a little bit late. Let's go back a little bit and just follow the progression of the snow that arrives over us this evening. So we'll go to 18 hours. This is tonight. Precip is supposed to start around 12Z. This is associated with that broad wave that was heading eastward. We're cold enough for frozen precipitation. And we'll look at this from another perspective in a little bit. We'll go ahead to 30 hours. Once things are been over, this is accumulated precipitation. So this is just as the trough axis itself is about to pass by us. But you notice there's not much in the way of any significant development of the weather system on this particular NWP forecast. Let's go ahead another 6 hours, please. So this kind of just dissipates, kind of fizzles out as it continues eastward. In some of the other forecast models, this does get down to about 1,012 or so hectopascals, but it's not a really intensifying storm. It's just really a trough passing by. We don't see much in the way of a significant surface development associated with it. The surface cyclone is in line with the upper trough, the thermal trough, so it's just the reflection of the PV and island moving by, at least in this forecast. And we go ahead, another 6.
So there's 1 inch of the 9 we need, maybe.
Possibly. This is just a little bit of lingering stuff. I'm not going to make much of that. But you can see the next weather system with a trough that moved in from the west coast. We're now beginning to see significant warm convection occurring out to our west, which doesn't bode well for us if you want to get frozen precipitation. If this next cyclone is much more intense, the varicolonicity will be closer to us, but we're also going to get into, probably higher thicknesses, higher surface temperatures as well, and we'll probably, it might be more liquid. So if you want to get more snow, you want to, set our new record, or a record for a late month worth of snow, this gets me a little bit nervous.
We all want to see that.
I want to see that, definitely. I love snow. Oh, actually, I'm going to quickly do something because I should put my call. Let's go to 40 hours, strong warm advection, and then finally go to 60 hours on this. And this is just before this is about to start again. This is Sunday evening, early Monday morning. We see the precipitation still up to our west, but the thing is, we're getting a sharpening upper trough. You can actually begin to see some undulations in the thickness pattern right here. There's the cold trough, here's the warm thermal resistance getting created. Very much unlike the first system that goes by that's a little bit weaker, where we didn't see much in the way of a phase difference between the thermal wave of the surface and the upper trough. So this is going to be a much more dynamic system as it goes by. So let me skip this for a second, go to the final tab that I have up here. There might be, this is a GFS. So this is, let's just go to the GFS for a second, this tab that says GFS. This is accumulated precipitation or snowfall through 84 hours. Through 84 hours over the upper Midwest. GFS is giving 5.3. We can kind of just quickly go through, set up here. The ECWF through Tuesday, so Monday night, 3.7. The GDPFS, 6.1. GFS 5.3, not bad. 2 inches here. Sort of a blend of all models, about 1.8. All right, John, there you go. I don't even know what RDPS
How
is,
does a
but
blend of
it's
models
there.
go from 4, 5, and 6 to 1.8?
They probably have a lot of the other short range
Oh, okay.
models that aren't shown here.
Okay.
And UK Met, about 2.9.
All right.
I'm gonna have to run, but one of the neat things about this, and maybe you wanna look at this a little bit more in terms
Yeah,
of
we'll do
surface
that.
development, is the first system gives us a little bit of light precipitation, maybe 1 inch of slushy snow. It's the second one that comes through, I think Monday to Tuesday, that gives us a better shot, or not Monday to Tuesday, late Sunday and then Monday. Yeah, Monday. We get the next really good chance of precipitation. I think Thursday, that Wednesday, Thursday might not be as prominent, but
All right, I'll spend some time with it. Thanks,
Michael.
Michael. Let's just keep going, Pete. Maybe we'll look at surface forecast from the GFS. Let's go to just surface and precipitation. What is it? Oh, precip type, yeah, that one. The sea level pressure and precip.
Do you want the wider view?
This is okay, yeah, because we'll just, it's a couple of minutes here. Let's just go ahead through the event on Thursday and kind of see what's going on. There's a system's getting itself organized over a period of time, Tuesday and Wednesday. Yeah, let's just click forward through these. Oh, this is the trop easier. Every 6 hours is fine. So here comes, you can kind of see a cyclone developing here in northeastern South Dakota by Tuesday afternoon. Keep on going, please. And that's the storm of interest, taking its time to develop. This is Wednesday morning, so we'll have some rain maybe Wednesday morning. I think the whole thing kind of keeps on developing and staying, at least the earlier run I saw, it kind of stay centered over the state from this point on. Let's see if that still remains the case. This is the 12Z run. Yeah, right there's, how come it keeps on going?
It's because he's got the model comparison thing up there.
Yeah, we don't want to do that, so just one. Okay, it's snowing. I'm confused with where we are. We're at 12Z Thursday, but it's snowing. By this time, the cyclone's over northeastern Lake Michigan. Can we go back to 132? What's going on here? I've seen some things flash in and out that I don't understand. I guess we'll just take a look at let's go to the 156, so this will give us all the way through this snow event. And then go to 24-hour forecast precipitation. This is all from the GFS. This will be the last thing we look at. So, snow. And not Kuchera. I don't like Kuchera. This is the 24-hour snowfall. Okay, so 1.3. So it looks like this. Michael's right. That earlier today, the before the 12Z run came in, the Thursday event looked better than the Sunday event. Now it's the other way around. But so a little bit more potential for snow in the late part of the week. But lurking not far away are more substantial snow amounts. So perhaps if this thing evolves in a different way, we might find ourselves closer to one of those epicenters, getting us over the 9.2 required to set this ignominious record and rescue us from the boredom we have all suffered this winter. So that's what I'm hoping will happen. So anyway, keep your eye on Sunday into Monday, and keep your eye on Wednesday into Thursday as the thing evolves. This second storm, I don't want to spend any more time showing you how it evolves. You can do it on your own, but you'll see. It kind of evolves on a very much larger scale than the first one that comes through. At least that was true in the 060 forecast. So maybe that's the reason why the solutions will start to diverge, pinpointing where in that broad environment the heaviest precipitation starts to fall will be a bit of a challenge, because it's not a small-scale feature. Greg?
I think generally, for the next week, the dynamics aloft, the jet stream loads are very weak.
Yeah, we saw that for sure in the current.
And I think that just lowers predictability.
That's probably, that's a good point, yeah, that's probably right. No strong northwesterly flow, no strong southerly flow south of us or anything, yeah. So, maybe a bit of a wild card late in the week, but we'll see. So thanks for coming, and we'll see you all next Friday. Pete, thank you so much for driving, and Michael and Sensia, thanks for an excellent discussion. See you all next week.